All right, this is our power plant presentation. We are the Sparkyville Power Plant. Fulton Fun Devils. I'm Israel Carlaber.
I'm Sunny Sirota.
I'm Ahmed Nag.
For our power plant requirements, we decided that we need to generate consistent power for use in our community, and it should fit the aesthetic of that community. The power plant itself has to fit in a designated space, be portable and movable, because it needs to be, the city of Sparkyville plans to sell it to other cities. Also, another requirement is that it has to be pleasant to and in the environment, because it's supposed to be, there's a pro versus power plants like oil and coal, and it has to be cost efficient because we're dealing with a small community. So for the goals of our power plant, we opted to go with a water wheel and solar panels. We made a power plant that conforms to a natural aesthetic, and we made sure that it was portable. Both water options, high and low, offer consistent energy, and the solar option we decided was more practical than any other, and we made sure that it was under budget for maximum cost efficiency.
So in our decision matrix, we come to the conclusion that we have three main sources of energy and 4 criteria. The 4 are easy to build, power generate, and size, and which one will consume more or less time. So in these 4 criteria, we have seen that the water wheel and the solar had this the best, whereas in the water wheel, which will generate more electricity, and it will take less time to build rather than the wind. And however, the solar panels are just tapping wire solar panels, so they won't consume that much time as the wind turbine, because in the wind turbine we have to cut it on an angle and we have to keep it as smooth as possible. So when we sum all of those total points, we have seen that the highest 2 are the water wheel and the solar cell. So in our total cost, we have bought a lot of stuff. The majority of it we didn't need, or it breaks, so we had to buy extra. For example, the solar cell, we had to buy 3, but we only used 1 because 2 of them broke. And in the dowels, we bought 2 because we had an issue with the bearing, so we had to buy a smaller size. But however, overall, we've summed all the total, and we came up to a total of $31, and we've saved 36% of the total budget. So we upload this design by a formula that gave us the power output for the water wheel regarding 4 variables or 5 variables, which are the density of water, the volume, gravity, and the height. So our paddles are shaped in a concave shape, which will capture most of the water. So it can work on 2 settings, high setting and low setting, and it will generate electricity just fine. Regarding the solar cell, there are like 3 or 4 factors that affected the solar cell. The first one is how tilt it's toward the light. So we made a stand that make it as perpendicular as we can toward the light source, so it will capture most of the light and will generate more electricity. Second one is the area. So that why we went with the 3x6 solar cells, the tapping wire. And the 4th one is the light intensity. However, we had 2 settings, low and high setting. So we tried to maximize the area and how tilt is it toward the light. Regarding the power curve is a specification of the motor. So we have our stall torque at 0.03 Newton meter, and we have our no-load rotation speed at 2204 RPM, and we try to maximize both of them by having our motor work in the middle.
All right, and these are the documentations for our build. This is pictures from our second build. So what we did here, we cut out the sides for the water wheel and we started laying out the paddles. Right here was the first issue we actually ran into though. The paddles were cut slightly unevenly into the lopsided wheel. We cut them all at once instead of individually. I guess there was shifting when we were actually cutting them. So we found out they were lopsided when we actually started epoxying them to the sides of the water wheel. Another issue we ran into was we were using balsa wood, and we found out that if it just dropped on the floor at a perfect angle, it just split right in half, so we had to work through that. In our third build, the epoxy had solidified on the water wheel, and what we started to do was drill through it so we could put our dowel in that would be used in the bearing. We found out here was we used a 1/2-inch dowel, but we had 3/8-inch bearings. That was our only option with that. So we had to actually cut right at the edge and attach a 3/8-inch dowel so it would all work. In our 4th and 5th build, we started putting everything on the power plant base, and we started hooking up all the electronics. The platform for the solar panels were built, and we tested out the power plant and found out the splashing was a much bigger hazard than we thought it would originally be. So we had to work back real quick and make an acetate film and cardboard cover just to stop all the electronics from getting wet. Also in the 4th and 5th build, we started using solar cells and started tabbing them for use. When we started tabbing them to be used in the series, we transported them, and 2 of them actually broke in that process. So we had to make the executive decision due to our time constraint to only use 1. And then our justification of score, we projected our score to be a 22 out of 30, and then for deductions, we projected a -7 for a total projected score of 15 out of 30. What led to this, solar panels broke, so we're limited to using 1 instead of 3. Water wheel paddles were cut incorrectly, leaving the wheel lopsided. And then too much time was spent contemplating these mistakes instead of working through them or restarting them.
So in conclusion, the project was completed within the allotted time. However, we needed to be more meticulous in our execution to avoid mistakes like cutting. And also, the mistakes we made led to more wasted time because we had to decide what to do. Another problem that we had was that we lost a member of our group in the beginning, but we worked through these mistakes and managed to finish the build.
All right, thanks guys. So I have you guys permission to upload this to YouTube. Dr. Benson safe? Yeah. All right.
Yeah.
We refuse. Send me the copy as well.